you remember, okay, in control 1, you do the modeling of a system into what form? Huh? Actually, one more. Transfer function. In control 1, you do the modeling and convert to transfer function. Okay. So now I'm into to make some comparison between control 1 and control 2. However, in control 2, you will design the system in state space. Don't panic when you read state space. Please don't panic. Okay? Because state space actually is more easy than transfer function. Okay? Do you believe me? Yes. Okay? So, the transfer function actually is Laplace. I know most of you are allergic with Laplace. Are you allergic with Laplace? Huh? Are you? Do you allergic with Laplace? Do you allergic with Laplace? No. Okay. However, in state space form is in Alright, so we look at the slide. Okay, if you look at the slide, is it warm or I'm the only one feel warm? It's okay, the temperature. Okay. Okay. So this is what I explained to you before. A control system consists of subsystem and process of plants. So this thing we can call as subsystem, or we can call as a plant, or we can call as a process, assembled for the purpose of obtaining a desired output with desired performance given by a specific input. So it means that you give input to a system and then you get the output. Okay? This is what I explained to you before. And just alright. So this is the simplest form of a control system. So this one we already put the feedback and so on. Then it will become a little bit complicated. Alright. Okay, so this is example of process, plant, or system. Okay, in this case, what is the input and output of this system? So I will interview. If you look at the fan system, is a fan. Yeah? So can you give me suggestion? What is the input and output of the fan system? And then the input is? What thing is just so if you want to rotate the DC motor, you must have rotate. However, the push button only one to on. How about 6 weeks? 7. 7 sebelah kanan belakang. Where is it put? And then what is output? Okay. Because the controllers, you must know the system first before you can justify what is the input. Secondly, what you must make sure your segue position upright. So it means that must be always upright. If the segue is tilt, you can jatuh, you will fall down. Okay, you can fall down. So it means that the segue, the position of the segue must always at the upright position. Is it correct? Okay. So it means that what is the input? The input is the user angle. Because when you step on the segway, you must make sure your body up to the right. And then the segway will help you to maintain the position at the upright position. So it means that the segway, I can say this angle. The segway input is a segway angle. Is the angle. It's a motor angle. And then the output is a segway upright position. Okay? Is it here? Boleh lah. Alright. So if you look at number 3, the azimuth antenna. The azimuth antenna here, you can see this is antenna. Sometimes you want to catch the signal from the space. So it means that the input is how many angle do you want to rotate the antenna. Let's say if you want to rotate the antenna about 10 degree, so you use 10 degree rotation at the input, and then after that the antenna will rotate about 10 degree. Okay? And then this one, rubber arm lah. Okay, you give the position or coordinate to rubber arm, and then the rubber arm will go to the coordinate. So it means that for the rubber arm, the input is the desired coordinate. The output is the rubber arm will move to the given coordinate. So it means that if you know the system, then you will know what is the input and what is the output. So it means that not all the time the input is voltage. Because something like this, the input is voltage and then the output is the motor rotation. However, in this case, the input is the coordinate and then the output is the rubber arm coordinate.